And then with large import models, you have to do custom things. You gotta call somebody from the Fabricat team to come help you set up aggregations, to help you set up composite models, to make sure that your model refreshes fast. You gotta set up incremental refresh, and it can be a challenge. And you can see that you have some not so happy faces on the bottom.
So if we had a new storage model,
Yeah.
we call that DirectLake, what might that look like when you're looking at it like this? So, happy faces on the small models, just like in models. Whether you use DirectLake for import or not, in small models it doesn't really matter.
It doesn't really matter.
But large models, there's one fundamental difference here between import and direct query at the bottom is the smiley faces on the time to import model and model size.
Yeah.
So you're getting the best of both worlds. You're getting the access to data, you're not having to manage import processes. There's lots of good things that we're going to cover.
Wait, we don't have to worry about refreshes?
No?
All right, something new.
So, fundamentals.
So now, everybody's like, wait, I only need one data source. That's all you need with DirectLake. It only supports one data source right now today.
Yeah, so with direct query and import, you can connect to a very wide variety of data sources.
Yeah.
SQL databases, gateways, Excel, CSV. The DirectLake only understands one data source. Sounds like it's a problem, but it's a good thing because it can take many assumptions. It really understands and knows ahead of time how that data source is made up, and that's how it can bring the data in so quickly.
But the big difference between import and DirectLake is that there's no, when you first create that DirectLake model, there's no data in memory.
It's
So
a shell.
it's just a shell. And so,
Columns and table names and relationships, but no data, yes.
and so with the import, you got to reach back. You got billions and billions of rows every night, or at some increment that you specify. You have to pull that data into memory, and that can be a heavy lift.
Yeah, so with DirectLake though, how does data get into memory? It's triggered by a query. So it actually sits there and waits until you start using the model. And then as queries arrive into the engine, it can pull them apart, figure out what columns I need, and then it goes and gets the data at that point very quickly. We'll put a demo that will show you how quickly it can be, and also how you can monitor what's being paged in. Now, data gets paged in and triggered by query. And a table with lots and lots of columns can be a mix. Some of the columns can be resident in memory, and others aren't necessarily resident in memory. So it can be a bit of a mix, and that's what helps keep the model size smaller as well, because you're only actually storing the data in the model that you need for the queries that it's having to serve.
And so if you never touch those columns, they never come to memory. So if I have a table with 15 columns and my reports or whatever you're using to query that model are only touching 10 of those columns, only those 10 columns move into memory. And so, Phil, question for you. If I query a single column, is all the data moved into it? Or if I have it filtered down to a specific year, is it just that data for that year?
Great question.
Yeah, I know, I asked a good question.
So, if I have 10 years worth of data in my lake house,
Yeah.
and I run a query that just says, give me the sales amount for yesterday,
Yep.
DirectLake will go and pull all 10 years worth of data in. So it doesn't just go and selectively grab the information it needs to satisfy the rows for that query. It actually goes against the entire column. And it'll stay in memory. So if someone then comes along and says, I don't want sales for yesterday, I want sales for last week.
Yeah.
Well, it doesn't have to go and re-grab the data, it's already there in memory. And if you follow these practices and you set up your Delta tables well, that operation is very fast. And we'll explain a little bit more detail as we go.
Just because we're not pulling all the data in memory, just because we're not running, refresh processes, that doesn't mean you need to deviate away from your best practices, right? You need to follow the same best practices with DirectLake that you follow with import and direct query. You need star schema. You need to make sure you reduce the high cardinality column. All those things are still applicable in this case.
And how long does the data stay in memory for? Well, columns can be lifted individually for multiple reasons.
Yeah.
There might be a need to, the machine that happens to be sitting on is getting busy for CPU and memory, and our systems will say, okay, we need to free up some memory. Let's have a look at the data sets that have got data resident, loaded into memory. But we can actually tell by looking at some metrics which columns haven't been touched for perhaps some time. We can just drop individual columns to free up memory to allow you to perhaps bring in new columns as well. This is much better memory than import, where you get all rows, all columns, the entire table for the whole lot at a time. as needed. They can also get evicted just after a period of inactivity, say 10 hours or so. So it's not common necessarily in the DirectLake model for the first person that hits it first thing in the morning to
Have to wait a little bit.
wait a bit longer. But you can implement caching new techniques, and there's a whole bunch of tips and tricks that you can apply to try and make that first load perhaps not be a user loading a report if you want to.
So there's some guardrails placed around this. And so each capacity has different guardrails, limits on row size, segment size, parquet files, and things like that. And if you exceed those guardrails, it can cause you to fall back to direct query. I'm not saying direct query is bad in this case, because the endpoint.
Now, you were saying direct query was awful before.
So direct query, if you have a bad DBA. You don't have a DBA. You don't need a DBA anymore, right? You need a data engineer. You need somebody that, really understands this. Not just a DBA who understands tables and columns. We got some different things that's going on here. And so there's guardrails to protect lots of things. But just be careful, and we'll talk about that a little later. But it can cause it to fall back to direct query. There's a property that you can set to make it only go direct query, only do DirectLake, or choose what's best in this scenario.
And there's some good examples where this is actually quite advantageous.
Yeah.
So if you get one fact table that happens to have, say, 30 billion rows, all your other fact tables are quite small, all your other dim tables are quite small, they can all be paged in really nicely, and any queries that touch those, we just use DirectLake and import like query experience. But you don't want to have to buy a SKU that's 3 times the size just to fit one table that's very, very tall. So perhaps we can accept that, all right, anything that touches that table, let's use direct query for, and we can save some money by not having to buy a bigger SKU that we need. So there's lots of good reasons why you can, having that DirectLake. So,
and then the last thing, I know we said there's no refresh required. There's a sort of a refresh that we need to do. We call it framing, and we'll dig into that. If there's time, we'll show a demo of how to do it.
we should speak up.
Okay, we're talking too much. We're talking too much.
Yeah.
All right. So, there's we have to talk about this. We have to talk about this here. And so, there's no calculated columns required. That's allowed right now, and no calculated tables. And so, a lot of people are pushing back, saying, I need calculated columns, I need calculated columns. If you go on Twitter right now, it's a very controversial subject. Saying don't have it's Chris here. And so him and Adam have been going back and forth about this. No calculated columns, right? And so there's some pushback. People are like, I need calculated columns. Create it in the source. Matthew Roach's got a good maxim. Go as far upstream as possible. Talk to your data engineer and have them create it in the lake house or the warehouse, whatever source that you use, right?
Yeah, no concept models. The third one is a biggie. Not to be used with views, for example. You create a view, which is very, very handy to create. This is the first thing a lot of people actually do in the SQL endpoint. And you cannot use DirectLake to it. So we always use direct query to it. Why is that? Well, a view can be very simple. It can be as simple logic as just select some columns from a table to make it smaller, maybe a little bit of formatting.
Yep.
But a view can also contain really complex logic with joins and group bys and involve lots and lots and lots of tables. And frankly, it's just too hard. So for DirectLake, when it's triggered from a query to go and figure out what needs to be paged into memory, it's just, at the moment, we haven't finished that. But down the track, I'm sure we'll have something, materialized tables, there'll be, we want to get your feedback in here, how this affects you. But at the moment today, if you create a view, which is fine, it'll just use direct query in that. You get the right result, but it's just an important thing to be aware of if you're using DirectLake.
And then, if you have security in your warehouse, for example, if you set up row level security or column level security, object level security, in your warehouse, it's going to fall back to direct query. So you need, go ahead.
And that's where security trumps everything else.
Yes,
we
that's
need to
right.
make sure that if you've gone to the effort to define some security in your warehouse, we need to make sure that that is being applied above everything else. So we'll sacrifice performance of DirectLake to make sure that the person A is only seeing data that they are allowed to see, nothing more, and so on.
Security is not important, I feel. So let's skip that. Let's skip security. Data types, right? So there's a limit on the types of data types. No binary columns, no datetime columns. You have a minimum of 4,000 characters. Seems like a lot of limitations, but honestly, it's really not. Once you start kicking the tires and do this stuff on the back, in the lake or the warehouse, it's easy to overcome those challenges.
Okay, so where can I use DirectLake and where can't I use DirectLake?
It's kind of limited. You gotta need a PSU or an FSU. That's where you can use DirectLake. No Pro, no Power BI per premium per user, no embedding. It only FSQs and PSQs. I think we should just stick to that. And so there's some announcements that came out. Zoe and Christian are in the room. Yeah, next slide. And so right now we say only warehouse and lake house, and Zoe and Christian are like, oh, it's so much more. Not yet, we're coming. Right? So, yeah, we do DirectLake, lots of other places. But right now today, stick to the lake house and the warehouse.
We need to update the slide,
Yeah.
because we announced yesterday that we can actually now connect semantic model, DirectLake semantic models to new sources.
Yep.
They still have to be Delta tables, it's
Yep.
still Parquet.
Yeah.
But we're now going to be able to use things other than the SQL input, which has some challenges, which being able to choose more options and Fabric is a good thing.
I'll fix this slide before we do it.
No, it's good, it's fresh,
All
it's
right,
new.
yeah,
It's
yeah.
exciting.
All right, this is all you, Phil.
Okay, so why do we actually go for Parquet? The decision to go for this separate storage and compute setup, DirectLake, hey, theoretically we could have chosen CSV files or XML files. So why Parquet? Parquet is actually really suited to BI and analytic type queries, simply because the column-oriented format, which I've got a couple of slides here that show the difference between row-based formats and Parquet. It's open source, and we've chosen a common format. So, as you're probably already aware, you take Delta Parquet tables that have been generated by non-Microsoft tools. They can be read by Fabric. Equally, the Delta Parquet files that we generate can be read by non-Microsoft tools. So we're open all the way through. That's one of the 4 pillars. I think we talk about the keynote.
Yep.
Talk about the column-oriented format. It's really suited to analytics. It both compresses it and improves our ability to get access and read data very, very quickly. Makes it easy to compress. I've got some examples of numbers to give
So
you.
Phil, this seems like that instead of analysis services doing all the work, instead of it doing compression, we're just leveraging what the Parquet file is doing.
Yeah, and there's a lot of similarity
Yeah.
in the layout of a Parquet file and the layout to how we like to spread our data inside analysis services.
Yeah.
And that's why DirectLake is actually so fast, because it's nearly a perfect lift and shift operation. We have to do a couple of little things in the way, but that's why it can actually be so fast. Because the data in the Parquet file format, we don't have to do much to. We can stick it on some super fast SSD premium file stored disks when it comes time to get data, and the layout helps us selectively get quickly to the data we need. And I'm going to show you that now. There's another little flip there. I want to keep moving along. So, CSV file format. Here's a very simple data set. We've got 4 columns, 3 rows. It's machine readable. We all know CSV. This makes sense. This is what a data set might look like. It's very robust. If I needed to do if I just wanted to sum up that last column value to get a number, I have to open the entire file and I have to scan the entire file. It's very difficult for me to jump to CSV to actually quickly get the numbers I want. So it's row-based. XML, this is, I can't even fit it on the screen actually. This is what that same data set might look like in XML format. Still quite human readable, but it's still again very row-based. So if I wanted to do a sum, produce a total of the value column, I'm going to cover a lot of ground to go pick out bits here and bits there. It's not a particularly fast operation. And you can imagine the Excel file here, so the Excel file is probably going to be bigger even than the CSV file. We've got Jason. Jason's like an elegant, sort of trendy version of XML.
Trendy version. The trendy version. All right. Fashionable. When I got some problems. Yeah.
Same problem. Row-based, if you want to find the sum of that value column, it's very difficult to get at. So what does Parquet look like? So the data is pivoted. In my head, I sort of go horizontal to vertical, and other people probably think vertical to horizontal, but it doesn't matter. The really important thing here is that the values that belong to the column are all really nicely coupled together very tightly. So if I needed to quickly perform a total of those same values, I can skip a whole lot of the file, and these files can get very large, that's important, to ignore a lot of things and say, hey, if I need everything you've got on the value column, I can quickly find it and bring it into memory to do that work. Now, one thing I just want to pause on here, inside a Parquet file, you generally have blocks of data. They're called row groups. The amount of rows in a row group can vary, but for those of you that know analysis services reasonably well, a row group is an exact match one-to-one with a segment inside analysis services. And that's an important thing to sort of think about when you're doing more advanced query optimization. How you organize that data. That's all I'm going to spend on that particular topic. Now, inside the Parquet file, if you were to open it in Notepad, it wouldn't be machine readable. It's actually as compressed as binary. It wouldn't actually make much sense, but logically this is how it's organized. But it doesn't store data like this. So notice in the store ID column, I've got store A, repeated over time. So that would use up a bit of space. What actually happens inside the Parquet files is it makes use of dictionaries. So a dictionary is perhaps, rather than type out the word apple, we'll put in the value of 1. That'll be its dictionary ID. And banana would be 2, cherry would be 3, etc. And so on. And the dictionary IDs are just numeric, they can compress well, you can do running encoding, so I've got a whole bunch of ones. I can, rather than just go 1, 1, 1, 1, 1, 1, I can just go 10x1 to compress even more. But one of the differences between a Parquet file and analysis services, and I mentioned that it's almost perfect, is that row groups can have their own unique dictionaries. So in one row group, apple can be a 1, banana 2, cherry 3. But in the next row group, apple might be 3, banana 2, and cherry 1, for example. However, over in analysis services, we only have one dictionary. So part of the work that takes place when you do need to go and suck data from the Delta Parquet file into analysis services is managing this alignment of the dictionary IDs. So card analysis can be a really important thing to be aware of when you're considering how long it takes to page data in. The lower the card analysis, the better, because you've just got n squared less number of values you have to try and map through. We've got a lot of good ideas on how to make this better, faster, so watch the space. It's not done by any stretch of the imagination, but it's just something to watch out for when you're thinking about Parquet.
But this is one of the reasons you still need to follow best practices. You have to, you can't abandon it. I've talked to and been on phone calls with a lot of people already, and they're just like, oh, we don't need to worry about any of the best practices we talked about. Import models, don't forget it. Don't forget it when you're going to end up on the phone with me, and you probably don't want to.
Okay, so B-order.
Yeah.
What's B-order?
It's proprietary, right? It's our optimization. It's a proprietary optimization for writing data to Parquet files, right?
Yeah. So what B-order does is it compresses your files even further, makes them even smaller.
Yep.
Now we've been working on B-order since around 2009.
And that's unbelievable, right? People they don't understand that we've been doing it that long.
Yeah, Fabric's only not even a year old. We're only the first.
It hadn't had a birthday yet.
So we actually knew that Fabric was coming that far in advance. No,
Yeah.
the reason why we've been working on B-order so long is because it's the fundamental algorithm that works when you are importing data to compress it, encode it, and all that sort of goodness. And we've refined it and improved it over a long, long time. It's something we're very proud of, something we're very protective of. You'll only get B-order on Fabric compute.
But there's another product that has a Z order.
That's not as good.
Okay, all right.
I've got some numbers I can show you later on.
Anybody use the Z order is not as good as Z order. Just want to let you know. All right?
Okay, but you're thinking red flag.
Yeah.
Okay, Microsoft, you guys can lock
Here we
me in.
go. Here we go. Right?
You're telling me the Fabric is open. If I do this B-order, does that mean I'm stuck now with you?
Absolutely not. Absolutely not. If a product can read the Delta file, it can read the V order Delta file that we created.
Yeah, so if you create a B-order Delta Parquet file,
Delta Parquet, yeah.
open it in a non-Microsoft tool, not only will it be able to run the query and completely give you the correct result, it'll probably do it faster than if it had run the same query on its own Parquet files that it generates. And I've got a slide that can show you that.
Towards the end, right?
Yeah.
That's it.
I think that's all.
Yeah.
So in practice, we took a bunch of real Microsoft sales data.
This is a real story. This is internal. We saw about 888 gigs of CSV files.
In CSV, which is nearly a terabyte.
Yeah.
And look, CSV is not designed as a great compression tool, so that's not unsurprising. Just simply converting that same data to standard Parquet, it came down to nearly a third the size, which is pretty good. That's expected. That's what we, that's Parquet in action.
Yep.
So this column store stuff running encoding does a pretty good job. Now, we applied V-order on top of this, and it came down to just 84 gigs. So a tenth the size of the original CSV.
Yeah, but think about this though. So a lot of people will call and say, oh, the max model size you can have in Power BI is 400 gigs. But you gotta think about, if you think about your raw data, and that's what a lot of people do, they try to do a one-to-one comparison between the data in their relational operational database to what they can store in analysis services. This is something you absolutely have to consider, because as you pull that data in, and you need to be very selective, still be very selective with the data you pull in, you have to think about the compression ratio that you're going from that raw data all the way down into this Delta parking lot.
Yeah, so you've got the max model is 400 gig.
Yep.
It would be typical to expect you to be able to cover 10 times that size,
Yes.
4 terabytes.
Yeah.
And you don't even have to have all the columns reasonable the whole time. You can be
Moving them in and out.
Now, again, this might be another red flag, because in other technical domains, when you aggressively compress something, you burn a lot of CPU and time, but then before you can use it, you actually just burn the same amount of time and CPU to uncompress it before you can get at the data and use it. But not only does Power BI analysis services, not only can it read the compressed data, it prefers it, it loves it, it can actually produce your results, do your sums, your running totals, your period comparisons, and give you the right result faster on 84 gig than it will do on 300 gig. So I really strongly recommend if you're playing with this, playing with other tools, do some side-by-side comparisons with Delta Parquet, largely better, generated by other vendors, other tools. And if you have a V-order version of the same thing, don't just look at the file size difference, run queries on the both, because it's another factor again of performance improvement, which is pretty cool. So I think we've done enough talking about.
No,
enough talking. What I like to do in these situations is, this is a wise man once told me this, I like to go over to my laptop.
Here you go. I'll pull up the chair for you. Go ahead. Go ahead.
Did I do that right?
Yeah, you did it right. It's good.
Okay.
It's just my words, man.
So I've got a semantic model here with some fairly good tables. It's empty.
Yeah.
How do I know it's empty? Because perhaps I've only just built it. But I want to double check. So I'm going to go to DAX Studio, which is hopefully still connected. And I've got a DMV here, which will share somehow. You don't have to worry about remembering this exactly. And if I run this DMV, I need to connect maybe. It's going to see if it's going to lose. It's running. Okay. A DMV is a query that you can run in a database that's not actually giving you the data inside the columns. It's telling you about the state of the database. And this particular DMV, and I'll make it bigger. I'll close that one down. In the results here, there's one row per column in the model, and it's telling me a few things about each column. So right up to the very end, the last two columns in this case are blank. Not a single row has a value in those, and that's telling me that my shell of the model has got no data whatsoever. So this is good. This is going to be our playground to start loading some things in. And the very first query that is that right? I might like this. So we're going to run a query. Remember how I said, how does data get into a DirectLake model? You have to run a query. That's what triggers it. I've got a very simple query here that Patrick is highlighting.
There we can. Okay, there we go.
Now, when he hits the play button, what happens? The piece of text, and it's just a string, gets sent to the database engine, analysis services. When that receives the piece of text, it converts it to a query plan. And in that process of creating a query plan, it figures out what columns do I need to be able to produce the correct results based on this query. And at the moment, this query is just doing a max of the column and one of the date tables. When we've got a query plan and we know what columns we need, it'll do a quick check. It'll run that DMV essentially, and it'll say, do the columns I need, do they have their data? And in this case, no, none of them do. So at that point, analysis services will go out to the lakehouse and will say to the lakehouse, okay, Parquet files, give me everything you have on this column. And we'll deliver the data back, and we'll jump to the very quick places, the parts in the Parquet file, load the data back onto memory, lay it out in memory. When that round trip operation is all done, it it can actually execute the query. And I think we saw that the Max holiday name was Christmas,
Yep.
for example. And now if I rerun the same DMV, and if you maybe move it up a little bit, is it running or?
I ran.
Cool. This is sorted by temperature. So the very, very top row, if we zoom in, I'll scroll back, is the column. Oh, that's a bit. Yep, cool. That we just ran that single query on. When we scan along, we can see in the DMV, the column that says the column is now resident in memory. It's got a temperature. It's telling us the last time that the column was accessed. So there's some really interesting things. But now we're in a state where my model is empty, but one table. So there's another query immediately underneath it that's evaluate the maximum value of a different column in my data table. I'm deliberately just doing some lightweight queries here so you can see the effect of this getting paged in. So Patrick's, my assistant here, is hopefully running a query. We've got a result. We're going to rerun the DMV, and instead of one column at the top, we'll hopefully glance over on the right hand side. We can see now two columns are now resident in memory. They'll stay in memory for hours, 6 hours, 10 hours, 12 hours. There's a variety of reasons why it might drop out of memory, but it doesn't matter because it's really fast at paging it in. Now, the date table we're running on is quite small, so it's been running pretty quickly. I've got a query here that's running over 1 billion rows of data. It's doing some aggregations over a couple of columns in that 1 billion row table. It's joining off to a couple of dimension tables. None of these columns in the process, so don't run just yet.
Oh.
We should practice that.
Yeah, we should practice that. Go ahead. Look, I didn't run it.
Was it fast?
I didn't run it.
Pretend you didn't see that. Because, like, as I said before, when he highlights that query, highlights the text, and hits the play button, hits the run button, you know, the text goes to these database engine. The database engine creates a query plan, figures out what columns I need. Have I got any residents of memory? None of them are residents of memory. I've got to go out to the lakehouse. And actually, in this case, the data's not even physically located in the lakehouse I'm connected to. It's going across shortcuts. So my lakehouse says, I don't even have that data. It's over there. So I'm going to have to send a signal out and ask to get 1 billion rows of data from these two columns, get that back, pass it up to analysis services. It's going to lay it out in memory, do all that dictionary alignment work that we talked about. And then finally, when it's all laid out in memory, which is exhausting stuff, we can actually run the query. And then how long did it take?
I didn't take long.
It was like a second. It was pretty quick.
It was pretty quick.
And there's a couple of reasons why it was quick. The cardinality, the tables have been cleaned up, the tables have got viewer. That's a really big thing. If I was to run exactly the same query on a non-viewer table, it probably would have taken 10 seconds to do the original page to memory, which is not necessarily terrible, but
I'm looking at this field, and so the query that we ran was rather simple. It didn't have that many columns.
nothing.
But I'm noticing there's some extra columns here that is pulled in, and it looks like it's pulling in those relationship columns.
Because the query involved columns and multiple tables, so we don't just get the columns we're filtering and grouping by and aggregating, we also need to make sure we're paging the columns that are inside of relationships. Now, if this stuff gets evicted, and if we go to lunch and have a little bit of that this afternoon, because this has been full, if we come back, we might run the DMV, and we might see that half of these columns have been dropped from memory. That's fine, it doesn't matter, because if I rerun my query, it can page it very quickly. I don't mind so much. It's going to make better use of our memory. It's, so that's pretty fast.
Yeah.
Cool. What are we up to?
Okay, Frank. So normally, when you have an import model, you have to schedule a refresh. You run a refresh, you escalate endpoints. You do so many things to get data in. With a model that's in DirectLake mode, you still need to run that refresh, but it does something a little different. And it's a concept we call framing. And so it's a point in time. If you think about when you're adding, when you're updating, when you're changing data in the lake house or the warehouse, behind the scenes, more Parquet files are getting created. And so we need to make Power BI aware, we need to make the analysis services engine aware of the changes that's being made to those Parquet files. Now, by default, and this is what Phil just brought up, by default, as you make those changes, Power BI will automatically sync with the lakehouse if you have this property set. If you're working in an enterprise organization where you have an ETL process that you're loading data, you have CI/CD where you're adding columns and you're removing columns, you're changing the schema, you probably want to turn this property off because you don't want it to automatically sync because you could produce some inconsistent results for the people that's consuming the reports.
There are definitely scenarios where you want to enable that property that I just showed you, which is a setting on the semantic model, where every single time data changes in the delta table, you want DirectLake. What it effectively does is it just sends a signal to the model and says, just dump everything you've got.
Yep.
And the next query that comes in will get the latest data, because I know I can page data very, very quickly.
Yeah.
And that suits some scenarios, but yeah, absolutely, there are other ones where the delta table could have transient changes a lot, and you don't want to have those changes immediately reflected in your Power BI report. You'll get inconsistent visuals, and it's not ideal. So there are plenty of situations where the first thing you want to do is go and turn that setting off. And it's up to you to control when you want to, what point in time does your report should use.
But if you turn it off, if you turn this property off, those changes are never reflected until you actually do a refresh of the model. So you need to issue a refresh some type of way. You can do it many ways.
Yeah.
You can do it through semantic link, you can use the schedule refresh,
You can click on the button in the UX.
you can click on the button in the UX.
REST APIs, Power Automate, even
A
pipelines.
even a pipeline, you'll be able to trigger the refresh using the pipeline. Yeah, that was one of my favorite things in the keynote that they announced. Yeah, that was nice. Yep. And it's really fast. Think about this. If you have a import model that has 1 billion rows in it, how long does it take to refresh that? Especially if you have a bad DBA. It can take a really long time. But if you're working with this, we're not pulling data into the model, right? We're just telling Power BI which Parquet files to read. So it's almost instantaneous. It's a really fast refresh. And so you can just add that to the end of your ETL process. You can say, okay, I'm loading my DIMs, I'm loading my fact. Go ahead and run this notebook to reframe my model, or run this pipeline to reframe my model.
So what it looks like in practice.
Yep.
Let's say I bring 3 rows of data into my lakehouse.
Yep.
1, 2, 3. When I do this insert, it generates a Parquet file. So if you actually get under the covers and have a look at the file systems in OneLake Explorer, you'll see a Parquet file appear after you do your initial insert. Now at this point, if I try and run a query, it hasn't necessarily been framed, I don't get any data. But when I perform the framing operation, and I run a query over table, I get results 1, 2, 3. That's expected.
So Phil, so I create my model.
Yes.
And turn the property off. And I turn the property off, and I build the Power BI report. No data's there. I'm not going to see anything. But once I run the refresh, only after I run the refresh will I see these 3 rows.
Yes. But now what happens? Because I've got that auto refresh
Yep.
set and turned off.
Yep.
Someone comes along and makes a data modification change in the lakehouse.
And I don't want to refresh.
Correct.
Will I see this modification?
No. Sorry. So what will happen now is someone inserts another 3 rows, going to 4, 5, 6. If I was to go, query the table in DAX,
Yep.
you won't see the 4, 5, 6. You'll only see the 1, 2, 3. Even if the column gets evicted, for example, we might have to move your data set off to a different node, for example. When you query that table, it goes back to the refresh point in time, which was after the first insert, before the second insert. The results will still only show 1, 2, 3.
So the thing is, right, so remember when I said you need to turn this off because you need to make sure that you're aligned with the ETL process? This is one of the reasons you need to ensure that you do that. Because as inserts and updates coming in, you can have, in transit, you can have inconsistent data. And if you don't have that off, this data will just be flowing in and out. And maybe you have late arriving dimensions or something like that. In fact, this causes serious problems.
And it's only when I perform a second reframe operation after that second insert that my DAX query will now show all 6 values. So again, just to complete the circle, we bring it in, we do another insert, add some rows. And these data modification operations don't change the original Parquet files. Every time you change data in the Delta table, it creates a new Parquet file. So this is what makes it actually quite easy for the system to work out what should be considered and what should be ignored when it comes time to paging data into memory. So we will always be very careful in particular to look at when was the last time a refresh operation took place, which was nearly 2 minutes, so it can decide what to look at and what doesn't. If you've got water training on, water refresh on, doesn't matter, we're always looking at the latest data. But there are situations where you might want to turn it off.
Is there any case that you can think of where I need to keep auto refresh on?
Oh, I think lots of cases. They're just small teams where you just, you don't care. You want to make sure every time anyone touches any data in the Delta table, Power BI will show that
Automatically.
Like a direct query, it's always showing the very latest data. So.
And if you're not making a lot of schema changes, if you're not making constant alter tables, adding columns, removing columns, adding tables, maybe a good reason to keep that auto sync up.
Yeah, here's a list of those places we mentioned.
Yeah.
It should be fast because all we are doing is just evicting everything from memory and drawing a line and saying what that point in time is. So it's quite handy. Actually, SSM is using Timsol because you find a grain because you can go and frame an individual table. You don't have to frame the entire database as well.
So I figured out how to do it with semantic link too.
Execute Timsol?
Yeah.
There's a method.
Yeah, there's a method. Yeah, I'm gonna do a video on it.
Yeah, you're going to figure out what that syntax actually is.
I figured it out. I got it.
Yeah, SSM.
Yeah, I did. I used it. I scripted from Engine Studio.
Fallback.
Yeah. Fallback is easy because this is something we've talked about. And I remember I was reading the blog post, Zoe wrote this blog post, or maybe it was Kai, but they collaborated on this. And so there's a property, you can set this property in a couple of places. You can set it in a web browser. You're gonna show it. Okay, you can set this property on the model itself. You can use a tool like Tablet Editor to set it, or you can use some script to set this. But you can actually go and you can control the behavior of whether or not you're gonna go constantly DirectLake, constantly direct query, or you're gonna let Power BI figure it out itself. And I like it because maybe you go, I never want to fall back to direct query. And so I'm gonna set this property so it's always DirectLake only. And so even if I'm outside the guardrails, and we're gonna show you a table here in just a little bit that shows all the guardrails, but if you're on an F2, for example, the maximum amount of rows you can have in your model is 300 million. In a table, if you have more than 300 million, it's gonna automatically fall back to direct query. And so what you can do is say DirectLake only. And so if someone creates a table in your model that has 400 million rows, it's not gonna fall back to direct query. It's gonna give you a nice little message that says you need to do something, right? You need to either reduce the amount of data, scale up, or figure out how to solve that problem. Or maybe you go direct query, maybe that's performant enough for you. But you can test that using this method.
Yeah, so I found this property on the semantic model itself. I go to the web model authoring experience, and I click on the model option here, click on semantic model, and then it takes me to the property that I can set. It's not even a save button. As soon as you set it, it takes place automatically. This is going to be something that's important to think about now that we've announced the ability for us to connect semantic models to things other than the SQL that won't have direct query options as well. So just to let you know, you can set other places as well, such as tabular editor, etc.
And so one of the things that's interesting though, because a lot of people go, we don't want to use direct query, but you can actually use this property. You say, let's go direct query for everything before you scale up, because maybe you're working on a budget and you can't scale up to a larger SKU, but you can switch it over to direct query and start running your reports and see if it meets the SLA for your report consistency. Because direct query is not that slow as it used to be.
Oh, that's it.
No, it's actually pretty performant. And so this is going to save you some money and a little bit of time.
But we kind of talked a little bit earlier in the session about what are some reasons why it might fall back to query, such as you're using views, you've got row level security or object level security defined in the warehouse, data volume issues as well. So if you're using a X64 and you're trying to query a 20 billion row table, we're not going to even attempt to try and do that in DirectLake. We're just going to go and use direct query, and we'll probably do a pretty good job.
Yeah.
There will be actually some queries, not yet, but we'll perform faster in direct query.
Yes.
Potentially analysis services.
Yep.
But the SKU size matters. So the bigger SKU you get, the higher the guardrails are. And we've got a chart here that is available on the blogs. You can search for it and look out. But the classic one that a lot of people probably think about would be the P1. I might just do this. So if you happen to have Lake House table with more than 5,000 parquet files, then we'll just fall back to
To direct query.
yes, every time you do a data modification operation, you create a new parquet file. So if you keep doing lots and lots of little small modification operations, you might quickly get to that 5,000 limit. So it's important to keep your eye on that. You can do things like optimize vacuum. There's some tasks that you can do to defrag and condense that. Rows per table. The one that I'm usually focused on is this middle column here. 1.5 billion rows is the limit on a P1 or M64 equivalent. And then it just doubles from there. As you double the skew, you double the...
So I got a question for you.
Yeah.
I got a question. So let's say I have a model. All my DMs are they're within these.
Yes, it does work, yeah.
But I have 3 fact tables.
Yes.
I have one fact table that's below the limit.
Yes.
Right, it's got a billion rows in it. But then I have 2 other fact tables that are above the limit. Let's say they have 5 billion rows each. If I only use that fact table that's below the guardrails, will that one go direct lake?
That'll be direct lake, yeah.
All right, so you understand what we're saying, right? So it's a table by table thing. So if I design a warehouse, some of the tables exceed the guardrails, some of the tables are within the guardrails. The ones that are within the guardrails, they're still going to go directly. Okay, so it's not a whole model. It's not your entire model. Go.
If you group by a column dimension table and you aggregate by the 2 billion row table, then they both go to DQ. It actually folds.
That's right.
They can produce
Yep.
a single, it doesn't try to do direct lake dimension.
But if they're on their own, right? If they're on their own, it should go direct lake for one, direct query for the other. But if we mingle them together, then it'll automatically go direct query.
Per sub.
Yep.
So, good to be aware of.
Yeah. And so another thing, in your lake house, in the warehouse, we automatically maintain the files for you. So we do the optimize, we do the vacuum and everything. In your lake house, you need to take care of these things yourself. And like Phil said, there's some operations that you can do to ensure this, like optimize and vacuum. And if you go into your lake house and click on it, there's a maintenance option that you can use, and it'll give you the ability to perform those operations.
So how do I know if fallback to DQ is kicking?
That's a good question. That's a good question. The first place,
yeah.
Well, the first place is performance analyzer. How many people? I'm not going to say how many people never used performance analyzer before.
Inside Power BI desktop.
Inside Power BI desktop. If you're going to use Power BI at all, we need to become very familiar with performance analyzer. We got videos. Phil's got some videos on our YouTube about it. You got to go check out performance analyzer. That was the first way we were able to figure it out, right? Then you can use profile, SQL profile, old school. We can go old school. You can use log analytics. And then with this new behavior, you can actually control it. So you can say, go direct link only, and if you get an error, you're falling back to direct link.
You've got time to do this as a demo?
We got 13 minutes. Let's do it.
Okay.
I say let's do it.
Okay. So you just you jumped the gun.
I did, I know.
And you're in the query before.
So excited, man.
Exactly the same query, but the column that we aggregate is over a 2 billion row table.
Okay.
So this is the same P1 instance, so it's outside the guardrails.
Okay.
So,
You know I get excited.
It is exciting.
Yeah, it's
I don't
exciting.
know if
I said I'm on the edge of my seat right now.
Okay.
But I'm not sitting down.
Server timing. So server timing is,
Yeah.
I'm going to run the
What's that five? See, it's not. I got you. Yeah, now Darren should fix that bug. Okay. So this is the 2 billion.
No, this is the billion row table. So this should be running direct lake.
And we're on the F64 or P1. Yeah.
I'm just waiting for it to get up, because here's a bit of a clue about whether it's working or not. It took 0.6 seconds to run. So what's actually happening is the information from certain timing is taking a little bit of time.
Let's just keep walking on it.
Turn it on. When this completed, it'll say in the server timings that it performed a scan. That's a clue to say that it used direct lake.
Yep.
I'm going to run it over a 2 billion row table, and it's going to switch from saying scan to SQL. SQL, that's in, I've done a direct query. So there we go. So down here, that operation of a billion row table didn't take very long, and it performed a scan, very quick scan. So if I come down here now, I have exactly the same query, but it's running over a 2 billion row table. It's outside the guardrails. So if I run that,
So we're gonna see SQL.
we should see SQL. All going well. The query will arrive. We'll say, no, it's too big. Because in framing, that's when we figure out how big these tables are and how big the columns are.
Yeah.
So framing helps us also understand which tables we're going to perform direct query over. It's a bit slow.
That's all right.
Waking up the Synapse database files to run this again the second time will only take probably about 3 or 4 seconds in direct query right now. It doesn't store any data, it doesn't page anything in. So it does perform like classic SQL. That took 16 seconds because I think it was just waking up the database engine, but it's a SQL statement. But it worked. We actually got a result, the correct result. And this actually not too bad, 2 billion rows over the whole table. So if I jump back to my model, and I'll change this property from automatic to be DirectLake only. And I'm not even going to hit the save button. It's working on it. When this station is working on it, I'm just going to go back and execute the same query. And what I should see is an error. Back over here and run. Okay, straight away it came up with an error. And the error, if I zoom in, we cannot process the request because the request would require a fallback to the query, but fallback is disabled for this data set, so we've got that different experience.
And it even tells you, right, the Delta table exceeded I think the maximum program or something like that. And so when you go set that property, if you have Power BI reports running on top of that model and that property is set, you're gonna get that little error that says, hey, can't do this. Your administrator or whoever owns the model set it so that it can't go outside the workloads.
And it's even an option to say, always go to a query as well. There might be some very good reasons, might be some interesting data that you want to use that way. So, performance.
Yep.
Okay, so,
We had 8 minutes.
we've got some.
9.
So when you are working on a DirectLake semantic model, I think there's 4 areas that, maybe 3 areas actually that you care about when it comes to performance. First of all is reframing. How long does it actually take to reframe? Now reframing can, when I said it was instant, if you do have a large number of tables and a large number of Parquet files, reframing might take a couple of minutes, simply because it's got to scan a lot of metadata and take a little while. It's still going to be way faster than perhaps what we report over billions of rows of data, for example, but generally it's not something you can be concerned about, but if it's not instant, it probably means you've got a large number of Parquet files, so you might get across with some guardrails, for example. Cold cache. What I refer to here about cold cache is the time it takes to load data from the Delta Parquet files into memory.
So the model's completely in.
Yep, like what we had earlier in the demo. So cold cache takes into account how long it takes. And things that can impact this are cardinality. Now we'll talk about those dictionary things. Some numbers I show you here have a column with 97 million unique values in. So the time it takes to actually page that, and it can be a lot of work if you're working with billions of rows of data.
But that first person that hits it, right? The first person that opens the report, that person will pay the cost. They will have to wait and they need to go get coffee.
Yep. But you might consider some cache warming.
Techniques.
Yep, such as in your ETL orchestration, in the notebook, you might want to run some hard-coded DAX queries, just do the max of certain key columns, for example, or you could be smart and run your DMV in your orchestration and capture the temperature, figure out what are the hot columns, and then just generate an array of
What if I put my notebook, I use a notebook, put the Power BI reports in a notebook, and have the notebook run, and run those reports for me.
Yeah, that's
I'm
one way.
the cache up. So, as part of my ETL process, I run that notebook, it loads those reports behind the scenes. So when my executives get in the morning, take a look at the reports, it just snaps because I've been on the cache up and all these things.
And notebooks can be scheduled to run every, say, a few minutes.
Yeah, that's right.
It sort of brings it into memory. The next time it runs, everything should be in memory strip, so it should be fast. If something's been predicted, pull it back into memory.
Could I collect information from those DMVs and then determine what's in memory, what's out of memory, and then determine if I need to warm the cache or not?
Oh, yeah, absolutely.
Yeah.
Write some great scripts. I wouldn't recommend this on every single model. Perhaps the ones that are key and important, your big bosses.
Yeah. Maybe Satya, right?
Exactly. And you don't want them going, why is this taking so long? Warm cache. Warm cache is what I think of as more cache is the DAX query speed. Once all the data is in, has been caged in, how fast does that query perform? And some experiments that you might want to consider looking at is comparing your 100% import versus your warm cache DirectLake model. But just be aware you need to make sure that you're testing apples with apples. So if you're going, hey, my import query is really fast, but my DirectLake is not as quick, maybe it's because it's paging in. So just be aware what the state of the model is before you run it. And this is not talking about the clear cache in DAX Studio that you can do. So just keep that into mind. And of course, SQL fallback, if that's kicking in, then that's going to have impacts on your performance. You just need to be aware if you are doing like-for-like comparisons and testing between import and a DirectLake model, just know that direct query fallback is kicking in. Reframing, we talked about that. Okay.
Talk about all of this. We just need to flip the slides. Just didn't flip the slides. Just talking. And we'll make sure these slides are available. And then we'll put a link to the document we were talking about, the guardrails and considerations for DirectLake. We'll put that in where we have the table, we'll put a link to that in that.
Okay, I'm a numbers person.
Yeah,
I promise I'm nearly there.
Yeah.
I'm a numbers person, so what I did was I took exactly the same billion row table, the same columns, and I had 4 different versions of this table. One with V order, the thing that I love. Exactly the same table, just built without V order. So I could look at the size difference, the query performance, etc. I took a version of the same table and I partitioned it like data in the lake house. It was just creating quite interesting stories. And then I had a final version which was V order and Z order. And I looked at those performance things.
So partitioning matters.
Yeah.
Got that.
That could be good and bad.
Yeah.
So, the 4 tables, hopefully you can see this okay.
Can everybody in the back see that okay? Yeah, okay.
Okay, so the top 2 rows, they're the same. Billion rows of data, 10 columns in each of them. The 3rd row down, the V order one is true, 3 of the 4 columns, etc. But the first metric we want to look at is probably the physical size of data on the disk.
Yeah.
And you can use my tool Delta Analyzer to help figure this. Just point it at a Delta table, run Delta Analyzer, it will tell you how much space is being taken up by the disk. And this is important to help you decide what SKU to go for. Do I need a X64 or double, or what are the thresholds that we can go to? But the straight V order to non-V order comparison in this case was 11 gig to 7 gig.
So it saves about 4 gigs, right?
And then finally, when the data was paged into memory, all the dictionary work was done, other things, it was pretty much doubled. So the non-V order, once it was loaded into memory, because what I did was I just paged it in every single column. I didn't do selected columns, I just said all columns and have a look to see how much space was needed. So the non-V order one is twice the size and nearly pretty much maxing out at X64. There's not leaving a lot of room between that and the 25 gig limit for things like caching and query and other things. So not ideal in this case. I think V order is going to make an X64 quite suitable for this case. And the Z order and partition ones were about the same numbers. We're not going to spend too much time on there.
This is the good stuff.
So cold cache, how long does it take to actually page the data? As I said, for all 4 cases, I just basically said select staff on the table and time how long it took to go in there. One of these columns had a really high cut amount, 97 million values. This is real life data that got anonymized as well. So the V order table took 2 minutes 24 seconds. I did it 3 times, and so you can sort of see it's pretty consistent. The non-V order was 3 times slower, which is that's what we were seeing with the CSV data. The example I gave you earlier. Partition by date key took a lot longer, 3 times slower to page in, but there's some good news coming about that in the next slide. And Z order was pretty much the same as
But the Z order is Z order and V order.
Yes, V order and
Z
Z
order.
order. So anyway, the middle 2 took 3 times as long to pull data into memory when we said just do them all. And then I ran three types of queries multiple times over these 4 data sets. And query 1 was just like a group by weekday name, filtered by devices Android, and filtered to the month of December 2018. Some pretty big numbers, and I just wanted to illustrate some quantity. So in terms of milliseconds, the query, the V-order one took 200 milliseconds. The non-V-order was 3 times slower. The partition one
That's
was
interesting.
fast. It was really, really fast. It took 3 times longer to page in, but because my actual DAX query, 1 minute, was really nicely aligned to the profile of that DAX query, you actually got some really spectacularly good compute. So something to factor in is don't just configure your models out and out for cold cache performance. You might want to consider some alternative techniques that actually give you benefits on query speed as well. And the same is for my query 2, down further. So I was throwing some things like distinct counts in and a query that took 1.5 seconds on the V order, took twice as long on the non-V order, still gets 94 milliseconds on the partition.
The thing though about the partition though, what if I go outside? So you partition by date key.
Yes.
What if I start doing things that's not?
Well, then that's like this third query.
Yeah.
So we're actually starting to filter and group on perhaps other columns. But hey, in DI, I mean, how many DAX queries have some sort of form of date as
Most
the group?
models.
Yeah,
Most
so
models.
something to consider. You've got to be careful not to overfit, but don't just focus only on how long it takes to page data in, because you can page more.
Yep.
Your query speed can benefit quite nicely if you consider different techniques. And this partition data in the third column has got V order as well, so it does actually have V order. So,
We promise. This is it. We promise.
Patrick, if I go from import direct query to DirectLake and I have a slow report, will it run faster in DirectLake?
It depends. It depends. It's consultant. I'm a consultant.
If you've got a slow report before, it's probably got some bad DAX, bad data model, just simply converting it to DirectLake isn't just going to beat silver bullet. It's
No.
still going to run slowly. You need to follow best practice. The
Yeah.
same best practices you would apply in import and even direct query
Yeah.
still apply. That'll set you up for success. Do I have to use DirectLake with Fabric? No, you can still consider, you can still use composite models, direct query, import, hybrid tables, aggregations, all those good things are perfectly valid in the Fabric world.
Yeah.
I had someone come to me recently, they had 28 gig of data, and they didn't want to, like P1 was 25 gig, they didn't want to get the P2 to go 50 gig. I said, make it a composite model. The model size they ended up with in memory was only about 4 or 5 gig, and performance of the SQL endpoint was very, very fast. So they were quite happy in that situation. They didn't have to use DirectLake. They did have another one that did. Incremental refresh, you don't need, aggregations don't yet work.
Yeah.
We don't have time for questions.
Sorry.
Very, very good.
Thank you all for that.